Let's go pre-cal, chapter 4, test review. I've got two problems to start off with that are very similar, but you'll have an opportunity to see them done two different ways. So first of all, if cosine equals -2/3 and tangent is greater than 0, find the values of the sine and the tangent. So think about what is given here. Our given information tells us that the cosine is negative, but the tangent is positive. So think about your unit circle and think about what quadrant that must be in. If the tangent is positive and the cosine is negative, we must be in quadrant 3, because in quadrant 3, both the x and the y are negative, which would yield a negative cosine and a positive tangent. So let's draw this given information relative to quadrant 3. So just draw a right triangle with a rotation in quadrant 3. And it doesn't have to be to scale, but just draw it in quadrant 3. Cosine, by definition, is adjacent over hypotenuse. So adjacent over hypotenuse. We can now use the Pythagorean theorem to find that missing side. So 3 squared minus -2 squared is going to equal our y value. So that is 9 minus 4. So y squared is 5. So that means that we have a radical 5 right there, and it is negative. So can we easily find the sine and the tangent now? Yes. So the sine of theta. So this is our sine, our theta right there. This is our rotation. So sine is opposite over hypotenuse, so -√5/3. And the tangent, we are expecting it to be positive. The tangent opposite over adjacent, -√5/-2, which of course is √5/2. So that's one way to solve a problem like that. And very similar problem again. This time, the given information is presented a little differently. First given is if theta is in between pi and 3π/2. So once again, if theta is in between pi and 3π/2, that means it's in quadrant 3. This one's straight up telling you it's in quadrant 3. Cosine, again, is negative. It's -8/17. Find the values of sine and tangent. Now, if we're in quadrant 3, remember that makes the tangent positive and the sine negative. So keeping that in mind, but this time, let's use a Pythagorean identity. So here's what we know. We know that sine squared plus cosine squared equals 1. So if we know the value of cosine, let's plug it in and let's use algebra and solve for sine squared. So sine squared plus the cosine, -8/17 squared, equals 1. So from here, sine squared plus, and this is going to be 64/289, because that's -8/17 squared, equals 1. I'm going to go ahead and transform that 1, rename it as 289/289. So sine squared is going to be equal to 289 minus 64, which I don't want to mess up any subtraction today, so I'm going to subtract on the calculator. 225, look at there, it's a perfect square. So we end up with sine squared equaling 225/289, square root, the sine of theta equals 15/17. But since we are in quadrant 3, we know that it must be negative. So the sine theta is -15/17. And then what else do we know? By the quotient identity, we know that tan theta is equal to sine theta over cosine theta. So sine theta is -15/17, and cosine is given as -8/17. And if we do a little bit of arithmetic here, we're going to find those denominators are going to cancel. And obviously, negative over negative, that will cancel. And we get a tangent value of 15 over 8. So there is our tangent. So 2 ways to do that problem. You could have drawn a triangle in quadrant 3, or you can use identities. This is the Pythagorean identity, and this is the quotient identity. Evaluate using your unit circle. Now, everybody is going to be filling out their unit circle the very first problem on our test. So I've got mine right here, and we are going to evaluate to get an exact answer. No decimal approximations here. So we've got 1/2 and then sine at 3 pi over 4. So we go to 3 pi over 4. The sign on the unit circle is the y-coordinate. That is root 2 over 2 times the cosecant of 2 pi over 3 squared. So we've got to follow order of operations here. So let's go to 2 pi over 3. 2 pi over 3 is right here. And the cosecant is the reciprocal of the sine. So the sine is root 3 over 2. So the reciprocal is 2 over root 3. Now you could rationalize it, but it's about to get squared, so no worries. Next, we've got 4 times the tangent at 11 pi over 6. 11 pi over 6 is right here. The tangent is negative 1/2 divided by root 3 over 2. So if we have negative 1/2 divided by, negative 1/2 divided by positive root 3 over 2, that's going to be negative 1 over root 3. We'll rationalize that in just a moment. So follow order of operations, and in doing that, we have to deal with that exponent first, so we're going to square this. So 1/2 times root 2 over 2 times 2 squared is 4. Root 3 squared is 3 plus 4. Let's go ahead and rationalize this little guy first. So let's multiply by root 3 over 3. So this is going to turn into 4 times negative root 3 over 3. I'm trying to see if I'm going to have a common denominator, which it looks like I am. So, okay, on the left-hand term here, 2 times 2 is 4. So it cancels with a 4 on the top, and we are down to root 2 over 3 plus negative 4 root 3 over 3, and there you go, we got a common denominator. So we are going to simplify just by writing it as a single sum, root 2 minus 4 root 3 all over 3. That is the simplified exact answer. Draw the rotation negative 17 pi over 3 in standard position. Give the coterminal angle that is less than 2 pi and also give the reference angle. So this is the way that I do it. Obviously, there are many other ways to do it, but I just prefer to count the thirds. So we're going to start with an x-axis and a y-axis. And I'm going to ask the question, how many 3's are in 17? And keep your eye on the fact that this is a negative rotation. How many 3's in 17? There are 5 and 2/3 remaining. So we're going to rotate negatively. So negative 2 pi, negative 4 pi, negative 5 pi, and then 2 more thirds. So we end up right there. So that is what our rotation looks like. Remember to show which direction that you're rotating to indicate that this is negative. So here is a negative 17 pi over thirds rotation. It is coterminal with pi over 3. And it also, because we are terminating in the first quadrant, we also have a reference angle. the same as coterminal here at pi over 3. So we did everything. We drew it in standard position. We found the coterminal, and we found the reference angle. Remember, your reference angle is simply the shortest trip to the x-axis. Everything's always relative to the x-axis when we drop an altitude down, when we find a reference angle. All right, kicking it back to trigonometry, back from honors geometry class, solve for the remaining parts of the triangle. So, what are we given? We're given a 74-degree angle, and we know the hypotenuse, and we want to know the adjacent side. So, if we want to know the adjacent side, and we're given the hypotenuse, it would make sense to use the cosine function, since the cosine, by definition, is adjacent over hypotenuse. So cosine of 74 equals adjacent over hypotenuse. We're going to cross multiply and solve for c. So c equals 28 times cosine 74. Please be reminded that if we are entering in degrees, we have to be in degree mode on your calculator. Mine is. So c is equal to 28 times the cosine of 74. C is equal to 7.72 feet for this particular triangle. And if I don't say what to round to, would you at least kindly round to the 10th place? So let's keep going here, and we could continue to use trigonometry, or we could just use geometry here in order to find missing sides. If we want to go after A, we can just use the Pythagorean Theorem. So 28 squared equals c squared, which is 7.72. And do notice that little c is opposite or being projected by angle c. And angle c is clearly the smallest angle. If this is 74 and this is 90, then 74 or 90 minus 74 is 16. This is a 16-degree angle here. Therefore, it's going to be projecting a fairly small side. And our side A should be quite a bit larger, but not as long as 28. So let's figure that out. 28 squared minus 7.72 squared gives us A squared. Whoop, that is supposed to be a minus right there. A squared equals 724.4. Take that square root, and we see that A is 26.9. So it kind of makes sense that A is pretty long because 74 is sort of a big angle. So there we go. There's A, there's B, there's C, there's our missing angle. We have solved for all the remaining parts of the triangle. A playground in the shape of the sector shown needs to be covered with turf. Find the area and cost if the turf is $12.25 per square foot. A sector is basically like a slice of pie. So we're looking for the area here. And in order to do that, we're simply going to have a fraction of the total area of any circle. So if the area of a circle is pi r squared, then our sector is going to be 85 out of 360 times pi r squared. Our r in this situation is 45. So pi times 45 squared. So this is a fraction of the area of a whole circle. And this fraction is based on the fact that this is a central angle and it is 85 degrees. So we're going to go to the calculator, and it's going to be 85 over 360 times pi times 45 squared. So right into our calculator, and we get the area is 1,502.1 square feet. But we found the area, but we've got one other question to answer, so area is done. Find the cost if the turf is $12.25 per square foot. So that is going to be taking our number here for the area and simply multiplying it by 1225. So times 1225. So we've got a total cost to put turf on the playground of $18,400 and about 41 cents. There we go. So be sure you're answering all the questions when you are reading through our exam. So that is it for our review.